All right, good evening, everyone. Welcome to the Vancouver Aquarium. My name is Jonathan, the manager of public programs here at the Aquarium. Tonight's program is a part of the Sea Monsters Revealed lecture series. The title of our program tonight is Monster in the Closet, Climate Change or Climate Regime Shift. And if you're not sure what that means, you're going to find out tonight. And I'm going to let our guest speaker, our speaker tonight, answer those questions for you. So our speaker tonight is Dr. Jeff Marliave. He's been here at the Vancouver Aquarium for 40 years, one of the oldest age classes that we have here at the Vancouver Aquarium. And he's published quite a few technical reports and journals, and has written some books, some chapters in books. Recently did some work on ocean acidification. He studies biodiversity in Howe Sound. He's also studied aquaculture as well. So I'd like to go ahead and invite Dr. Jeff Marliave to come on up and give us his presentation tonight.
Thank you, Jonathan. That is on. Okay. So we're calling it Monster in the Closet, but the thing that I'm really interested in is sit down front, please. People get confused when you talk about climate change, and I want to talk about climate regime shifts. And so right at the offset, I want to make it clear that when we talk about climate change, we're talking about a phrase that's maybe easier to grasp, which is global warming, which means the history in recent decades of burning a lot of fossil fuel, a lot of coal, petroleum, natural gas, is adding a lot more carbon dioxide to the atmosphere. And so that is very gradually increasing the temperature of our climate. But even you kids know that from one year to the next, your life experience is that the climate doesn't stay the same. It's different. You have cold winters, you have warm winters. We've just had a very mild winter. And that's what we would call natural climate cycles. And so climate regimes are natural cycles. And the big question then is, what will the interaction be between this gradual warming that we are inducing and the cycles that have always occurred? In Howe Sound, we study the natural history of animals that are interesting for us to go diving and look at. And some of them tell us a lot about climate. For example, this big photo in the lower right is of a glass sponge. And this is a photo taken late in 2011. In the fall of 2009, the whole thing turned pale and translucent, and we thought we'd lost the whole sponge, that it was going to all die. But parts of the tissue, and this is one cell, it's a very, very ancient life form, parts of it stayed alive, and by this time, that part was growing. And then later we saw fishing gear damage this very piece, and so we've had a very intimate relationship with it because we've seen all kinds of changes to it in time. So if we're going to talk about climate, of course we're going to have to admit that there's the International Panel on Climate Change, and I'm an American citizen. My siblings are certified climate deniers, climate change deniers. It exists, and we have all these important models. So I just want to skim the surface and make this simple. We have to understand that at the University of Washington, they talk about PDO. That's the Pacific Decadal Oscillation. And that is a model that basically looks at sea temperatures in the spring and the summer, and it works in river flood levels, hydrographs, because those people are interested in salmon survival. And so they come up with climate regimes that have no bearing whatsoever on the climate regimes that are identified by ENSO, which is El Nino Southern Oscillation, and it's also now called ONI. As of last year, you have to remember ONI, Ocean Nino Index. That's, a little easier to trip off the tongue, supposedly. But the ONI Center looks across the equator, the whole Pacific. They're looking at sea surface elevation, and this is the one model that is used most on big climate models. And so I'm going to just say right now that we don't study salmon, which live in the surface layers of the sea. We study animals that live on the seabed, and our animals slap us in the face and say, this El Nino is real, listen to me. And so we're born-again ENSO believers. We really dog the site that tells us now in real time whether it's La Nina or El Nino. Very different than it was when I was younger, when they used to say, hey, that was an El Nino 2 years ago. Well, ask a Peruvian peasant. They know in real time, but modelers have a hard time pinning it down. And so the PDO regimes just don't line up. And so we're going to dismiss them, realizing that it's axiomatic that all models are wrong. Humans made them. They're not perfect. But some models are useful. And so PDO seems to actually be a useful model for studying salmon survival. And so maybe we've got a separate rule book for the oceanography of the surface layers of the sea in toward the shoreline of North America and up in the Gulf of Alaska compared to the whole ocean, including deep sea and along the seabed. Maybe, I don't know. So let's go to the National Oceanic Atmospheric Administration Climate Prediction Center, which is the ENSO or ONI Climate Center. And the years where they have blue numbers, that's La Nina, and where you see red numbers, that's El Nino, and that basically means in North America that the winter is warmer than usual in an El Nino, the red numbers, colder than usual if it's blue. Started keeping records around 1950, and the rules, across the top you see these 3-month periods. So this is August, September, October. So you basically have 12 periods centering on the 12 months of the year where they average out what's called the anomaly. So if it's more than 0.5 degrees out of the average, then if it's negative, that's toward a La Nina. And if it's positive, that's toward an El Nino. And you have to have 5 of these periods in a row for them to actually flash the colors up on the website. So there's been an armchair debate forever amongst the physical oceanographers saying, should it be an anomaly of 0.5 or should we go with 1.0? And some people talk about strong ENSO events, which are 1.0. Our animals laugh at this because they tell us that you need an anomaly of 1.2 or 1.3 or greater for it to be significant. And so we really do see that really weak ENSO events, like this whole year, yeah, the whole thing was in the red, but it was all really, really low anomalies. So if we go into more recent history, in fact, at the turn of the millennium, there was a whopping huge El Nino, anomalies as high as 2.4, 2.3. That was a really serious one. And then we had 3 years in a row, the first 2 of which were strong La Ninas. So you look at the middle of the winter, 1.3, 1.5, 1.7, really cold. And it is really well accepted that this induced a climate regime shift. The turn of the millennium involved a change in climate. I will say, though, that I've looked hard at this literature because we've actually published some stuff on it, and no 2 papers agree. No 2 climate regime shifts have borne any strong resemblance to any other. There's no real concordance, so take it with a grain of salt. But hey, I'm raising my hand and I'm saying that 2009, 2010 was a strong El Nino, and the 2 recent La Ninas amount to a climate regime shift. Our animals are telling us that. So we're saying it. Why not be the first to say it? I don't know. Maybe we're right. Maybe we're wrong. Going even more recently, right now, in 2014, the American government predicted a really big, bad El Nino. And I think that was a little embarrassing. This is as weak an El Nino as can technically be. But as of last week, and more in the media this week, they're saying it's really going to develop into a really big El Nino. I don't know. Let's take it with a grain of salt, see what happens. It'll be very interesting because if we have a huge, strong El Nino, follow some La Ninas, maybe, I don't know if you can get climate regime shifts on such a short order. The idea of decadal oscillations, climate regimes don't, maybe a couple of them have lasted about a decade, but that's a bad rule. It doesn't get followed. So that's all you're going to see of numbers, okay? Now you'll see graphs, and so we tried to make it easy by making it colorful. And this is seabed biodiversity, just all the different species of animals that we saw in the different climate regimes before the turn of the millennium. And if you stand out looking and go, well, hey, you know, the green bars, the last climate, you got more species and you got the least in the first one. You just got better at identifying animals. That's all it is. There's nothing there except improved taxonomic capability. And two of the people who did all this work are here in the audience, so I can joke around with them. But when we then changed the rules and said, okay, then only look at the species that you knew how to identify right at the beginning. And if we do that and base it on just the 328 species that were being identified in these surveys, and both these last graphs are at White Cliff Park, which is probably the most dived site in Vancouver. In fact, the last decade before the turn of the millennium had the highest biodiversity, and it came down after the turn of the millennium. We didn't know how to identify fewer species, so that was real. We think that was real looking at White Cliff, where we have by far the most dives. But we can look a little more broadly than that. And we've published a little book that has what we find to be natural zoogeographic regions according to seabed biodiversity. And it does vary from region to region because, of course, west coast of Vancouver Island, for example, shares a bit of the warmer climate of California and a bit from up in Alaska where it's cold, but it's wave-pounded, it's open coast. It's very different than the protected inside waters. And we have very different biodiversity in these inside waters. And we find, in fact, that we're down here, so White Cliff is right there. But Strait of Georgia is quite different from Johnstone Strait immediately to the north and Puget Sound, the most inland southern arm of what some people call the Salish Sea. And so if we look at the biodiversity in those areas, a little bit cumbersome, but in fact, Strait of Georgia, there wasn't much change over 3 periods. And here, we're taking 1977 right through the turn of the millennium. We're omitting one supposed climate regime shift that not everybody agrees about. Not all the oceanographers agree that it was real. One thing that is coming out in the literature is that physical oceanographic indicators are probably not as strong as biological indicators. But you'll notice that Johnstone Strait up here in the upper right and the lower right, Puget Sound, had definitely more species in this middle period than they did after the turn of the millennium. So if we say, okay, well, maybe there was a climate regime shift in 89, and we go to 4 periods, and in fact, it is, again, just like we saw at White Cliff Park, the green spikes have it. That last decade before the turn of the millennium had the highest biodiversity. And when we look carefully at the species that are actually winking out or emerging, it's trace abundant species. It's the species that are rare in a particular area that tend to make it or break it in one of these periods. But next you have to ask the question, what is it about a climate regime shift that can cause a significant decrease in biodiversity? How can this happen? Is there any explanation we can put on it? Well, the turn of the millennium, something happened that started to really bother us. It took the better part of the decade, but we realized that in shallow water dives below the intertidal region, below what you can see at low tide, this particular starfish, the sunflower starfish, was just super abundant. They were everywhere. And they were at a huge abundance through that entire period. And then where we're saying that there was a climate regime shift, in fact, their numbers started dropping around 2011. So in 2013, when this picture was taken, that's not actually the highest density they got to. And this is our biggest, fastest, meanest starfish. They can eat virtually anything they can get into contact with if it has animal tissue. And note the date. That's October 9th, 2013, up the head of Burrard Inlet at a good distance from the port of Vancouver. And 20 days later, this is the exact same rock. And you probably can't notice it, but there's where is he? Right here. That's a baby sunflower star. The babies didn't die, but all of the adults very rapidly dissolved. They just melted, and divers couldn't help noticing this because it was really disgusting. It was quite hideous. And what you see beside the rock, these drifts of white, that's pussy goo from dead sea stars and little tiny body parts. It was pretty gross, really pretty gross. And you can see that not much marine life existed on the rocks where the sea stars had been. They'd been eating everything. So that's very likely, in diving depths, something that affected overall biodiversity. So what happened later after October, we started noticing huge numbers of little tiny green sea urchins. And of course, the sea star feeds on green sea urchins. And at first, seaweeds were the first thing. It was really starting to look pretty with the sunflower stars gone. We thought, how nice. And then we noticed these little urchins actually started getting bigger in front of our eyes. And pretty soon, there was no seaweed left. No seaweed anywhere. And in fact, these urchins grew faster than the literature tells us they're capable of growing. And so it's not uncommon to see what's called an urchin barren. Sea urchins and sea stars are in the same group. They're echinoderms, and it's one of their biological characteristics that they can have explosive growth in their population size, and they come and go rapidly. And so, in fact, we're finding these green urchins also have a densovirus. So disease may be one thing that levels their populations regularly. But if we look at what's called the ecology of food web, in fact, sunflower star is an important predator of seabed animals like green urchins, and the urchins themselves tend to be herbivores that eat seaweed. And this particular seaweed, called agarum, is the exclusive nursery habitat for BC's spot prawn down at the bottom. So the sea star has a negative impact on the urchins. It eats them. But the urchins have a negative impact on the kelp. It eats it. The kelp has a positive impact on the spot prawns because their larvae settle under and it gives them cover while they're in their very smallest, most edible stage. So if you remove, or if you look at the sea star, it's indirectly, the dashed lines show that indirectly it's having a positive effect on the seaweed and it's having a positive effect on the prawns. So if you eliminate the sea stars, then in fact, the urchins start having an indirect negative effect on the spot prawns. So with no real kelp beds left last year, we saw a nursery failure. There was really no real settlement of spot prawns. And that's not completely unheard of because some years the prawns just don't do a good job of reproducing. The plankton isn't quite right for their larvae to settle. But we see even less seaweed this year. And so we think there's very likely going to be another nursery failure. And the catch with this is that the spot prawn is a hermaphroditic species. It starts its life in the adult population as a male and turns into a female. So that by 2016, 2017, we're going to have an essentially all-female population. There could be a problem in terms of them getting their eggs fertilized. So that would be a negative feedback loop of reproductive failure. So I've come out and said it. We have to think about the possibility that as a result of climate regime shifts and sea star die-offs and things, that there may be a collapse of our prawn fishery in the inside waters starting around 2018. So these climate regimes and such do mean something. The consequences can affect people. Now, I talked about carbon dioxide in the atmosphere from burning fossil fuels. And the Vancouver Aquarium has always kept records of its seawater quality. And so we published a book chapter in 2011 that looked at seabed biodiversity and such, but it also looked at our pH records. And so what modal means, the dots on the graph, are the most frequently occurring pH value. A pH of 7 is neutral. Freshwater rivers can be a pH of about 6 around this part. They're quite acidic. The ocean, with all its salt, is very basic. It's very well buffered. And so the high open sea is usually a pH of 8.3 and 8.4. And around the rivers in the Pacific Northwest, this is the least salty part of the world ocean. And it's always been a relatively low pH. But what we see has happened over the years is the pH has been decreasing. And people are actually more interested in the extreme events, like the really extreme low pH in 2001, which is enough to dissolve shells on planktonic larvae and such. And to me, at the time we put this book chapter out, it just looked like typical noise. The data varies, but there's a downward trend, right? More recently, though, if we add the data in the last half decade, and if you think of what our animals are telling us, yelling at us that, hey, this was a climate regime shift. Then if you look at the two really well-accepted climate regime shifts, the end of the 70s and the turn of the millennium, you see that there was a sudden rapid drop and then a bit of a comeback to a pretty level plateau. And this climate regime shift that our biodiversity records tell us is real is not real to this physical oceanographic parameter, but it leveled out at about 7.7. And then after the turn of the millennium, it came to a new lower plateau that kept hitting down as low as 7.6. So on average, it's actually a little bit lower. So right now, it's risen up again at a climate regime shift, and now it's starting to drop. And what we have to do, it's down to 7.6. If it keeps going down and it plateaus at another low, that may indicate that ocean acidification is related in a step function manner to climate regime shifts, which I can't explain, but it appears as if this may be the case. And if this is true, then what we have been seeing here around Vancouver, in fact, we're already seeing what appears to be close to 3 points of acidification drop in a graph that's well under half a century. All these IPCC models that my siblings deny vociferously are saying that we could see 0.3 pH points drop over a period of a century. So yeah, you have to take models with a grain of salt, but what we're actually seeing in real life here suggests that maybe none of these models are extreme enough in their predictions in terms of the rate of acidification. That's kind of spooky, but this is what we're actually seeing. Now, I want to turn to something that's a little nearer and dearer to us, which is a type of seabed life that's kind of special to British Columbia and special to Howe Sound, right on Vancouver's doorstep, and this is called a glass sponge. This particular species is the cloud sponge, and you can see these little squat lobsters are telling you it's great living habitat. And they love to live in around it, and rockfishes that are big enough love to eat squat lobsters. And so you do get a little community building up around this type of thing. And this is the one that I talked about that lives on rock that we saw die off. And right down below it, a few meters down the slope, there's another big cloud sponge that never got affected by the El Nino. It's just enough colder. And it was temperatures around 10 or 11 degrees centigrade that probably hit it hard. If the sponges are growing on rock, then we call it a sponge garden. And there is a very significant difference. This is where you see terrific nursery habitat for newly settled rockfishes because they can hide in the sponges. And it's wonderful to see hordes of baby quillbacks swimming in front of you. You get close enough and poof, they all disappear like little gophers down holes. And they're hiding in the sponges. But they actually come out and they feed on the tiny animals that live around tube feet of soft-bodied animals that live on the rock that won't go near the glass spicules in the sponges. Much higher biodiversity on a sponge garden than in a sponge reef. A sponge reef, also called a bioherm, is where the cloud sponges grow on existing dead bodies of previous glass sponges. And perhaps because of climate regime shifts, we're learning new things about these reefs that have us really fascinated. Now, it had been thought that these reefs went extinct on this earth in the Jurassic period. And they had been the largest living landform in the history of the earth. They formed the basis of some of the rock structure in the Pyrenees all the way to the Alps, all the way across Europe. There was one spreading. And then in the late 1980s, they discovered living sponge reefs up in northern British Columbia. And today we know that they're up and down the coast of BC. And in fact, here in Howe Sound, right near Vancouver, is the only place in the world where you can dive on a small number of them with compressed air. So we're lucky we get to dive on these glass sponges. And this is part of that recovered sponge after a big chunk of it got sliced off by fishing wire. And so the lower left, May of 2012, you can see it just sliced, just like with a cheese wire. And then by December, remembering that this was a La Nina period, it was really cold, we see that the tissues were already repairing. And that was really contradictory to the literature. And it turned out, remembering that scientists couldn't tell in real time whether we were dealing with El Nino or La Nina in the 80s and the 1990s, all the literature purporting to show extraordinarily slow growth and no capability of tissue recovery from damage was based on observations conducted during El Ninos. So we've been really excited the last few years to be in a La Nina period. And so the question is, are biological responses good indicators of climate regime shifts? In fact, just as a little aside, this is a chunk that was broken off by that fishing wire, and we stabilized it like setting a broken bone in a plaster cast by putting it in amongst rocks, and it kept wafting around, and we'd add more rocks until it finally held still, and eventually broken pieces fused to each other, and then the sponge fused back to the rock, and now it's growing really well. So we've talked about the urchin barons and the sea stars. This is one and another species of the genus Desmorestia, which are acid-loving seaweeds. They have sulfuric acid in their tissues, and they've always shown up as trace abundant seaweeds around Vancouver, but never really consistently until last year. And suddenly we're seeing real abundance of them, and we're seeing this increase in ocean acidification. And I'm crazy, and I love it that the botanists all tell me I'm nuts. Can't have anything to do with ocean acidification, by saying, hey, they got sulfuric acid inside of them. Maybe it's okay for them to be in water that's a little more acidic. Who knows? We're going to really be interested to watch this year to see if the acid seaweeds get increasingly abundant around Vancouver Harbor. Now, we're trying to get volunteers, divers, some of whom are in this room, to go diving on sponge reefs. And what people with ROVs and big oceanographic ships have had to do on deeper reefs is to throw marker pipes in the mud, because it gets so hard. They change their shape like cumulus clouds. So we have these bar-coded pipes in different parts of this reef and instructions how to do the dives and all. And Donna Gibbs, who's here in the audience, is on the 3 green stripe stake. And so the idea is, whether it's photos or videos, you want to have the stake in the frames so you know where you are, because we've had to just give up on all our old videos because we can't tell exactly where we are. You get lost so easily. And so she's moving west from the 3 stripes and going over to the 2 stripe one. And this is a reef that basically collapsed after the 2009-2010 El Nino. And now this is in 2014 in a La Nina period. It's growing up far more rapidly than they're supposed to be capable of growing. We think we haven't exactly proven their growth rates, but we're now getting records where we can say, aha, that's the 2 stripe green stake, and there's a battered rockfish there. And this happens to be a full sun daylight day where the visibility was perfect in the surface waters, in the midwaters, and at about 100 feet depth, which is totally unprecedented. So you're seeing further up and down the reef than you normally can. It's usually like a night dive. But you can see the silt that has made all the dead bodies geologically stable. That's what gives this a sort of a long-term life expectancy. And now we're down to the single stripe. And in fact, since the time of this video, we have seen one sponge right near this stake fall over, and she's about to pan left, and there it is. There's this very tall one right up there, and it basically got so elaborate and so top heavy that it broke and fell over. And there are other ones that have broken and fall over and then start to grow in an arch form by growing on the top side more, so that they may actually, if they hang up and are stable like a cast bone, they may be able to keep growing. And so we're hoping that we're going to start getting records. There's, again, behind the pipe, you can see that tall, very elaborate, exotically shaped thing. Unfortunately, it grew big enough, tall enough that it fell over. But this is the kind of record that we're trying to make sense of, and capturing still frames. And you can see baby sponges, all that sort of thing. The frame, you notice, is bouncing around. This is called de-shaked. She was excited. It was a sunny day, and so it was kind of a bouncy video. And so instead, the video is stable, and the frame shakes. This is the same reef back in 2010, right at the end of an El Nino winter. And the sponges then were over 2 meters tall. Everything you saw in that last video, they're maybe a meter tall, maximum 4 feet or so. But this grayish cast at the time when this guy I was guiding him through and he was filming it, and I thought, this is the same reef. Well, in fact, all the gray stuff died. This white stuff up here, which is top heavy, if this sort of undercut got unstable, then pieces would fall. And on that same dive, this is just this week, I spotted this. hard to see, but this is the edge of the reef in a different area. And in the middle out here, there's something on the bottom that you can't quite see. As soon as he panned away from the reef, the camera refocused and caught this up here, which is a dead fragment of sponge that died with a bunch of living tissue that had been the uppermost on the sponge. And it happened to be right next to two black pipes we had pounded in, and we did that in 2009 because there were no sponges anywhere around. We were using this as a reference frame to start shooting video of the live sponge. And very shortly thereafter, these two black stakes here had this drift down below them of great big sponges. And we went, well, how on earth did that happen? Well, this is the fragment that you saw from April of 2010. And this is just taken a couple weeks ago. So it's a way that these reefs can grow back up after they've been crashed down by an El Nino or by fishing gear damage. And technicality for them all, a piece being one cell, this tissue may, technically speaking, be immortal. Thank you. And any questions? Yes, there's a question over there. Jonathan, you going to take a mic over? Or should I
Yeah, so we have a question. Do someone have an answer? Okay, hold on.
I just want to know how often you go back and film, like how often?
We used to only manage with the sponge reefs to get there every year at the best because, hey, we never had any money for looking at these things, and now we've got a little tiny bit of money and we've got other people into various reasons. We realize these coated stakes, last week I took footage of one of the, quotes, black striped stakes, and in front of the two black striped stake, a whole portion was completely dead, and the underside of the rest of them, where I know I put all of my stakes at beautiful looking sponges. I mean, you wouldn't put it against stuff that looks dead. And in February of this year, it was perfectly alive. So the more we go back, the more we realize we have to go back more frequently than we expected. And if this does turn out to be the mother of all El Ninos, oh boy, we're going to just have to live on these reefs because things may happen very rapidly. What I haven't seen yet is the whole reef drop. There's another reason to have these stakes there marked at the soil level and everything, and see how fast it can recover when we get to another natural shift toward colder climate. Does that answer yet?
See, we have a question up here.
How long did it take for the sea urchins to grow all the way?
Ah, good question. The scientific literature would tell you, son, that it takes 5 years for them to grow up. Try 3-4 months. So, hey, that's the North Atlantic where someone documented 5 years, probably under very average circumstances. And this was, I don't know, maybe special. So, yeah, in a half a year, we actually had reproduction by some, and there weren't urchins around.
When was your last dive?
When was my last dive? My last dive was last Thursday. Her last dive was today. Her last dive was today. Does that answer it? Okay.
I have a question for you, Jeff. I'll get to you guys in just a sec. So what's the take-home message for folks from today's talk about climate change, regime shifts? Do we need to be, is it all happening naturally? Do we need to, like, what is kind of your big message today?
The take-home message is we have to stay tuned, and we have to, the question about how often do you go back, we're going to have to be more and more vigilant to look at things that seem to give us indications of what's happening as a result of climate changing. And then we have to be open-minded enough to ask ourselves, hey, is this worse than any, if we get anomalies of 3 or more, I'll be the first to say, hey, this has never happened before. This is probably global warming speaking. And then we'll have to see what happens that isn't going to shift back. Some things may change in a one-way direction. We know when we fished out the cod on the Grand Banks, it didn't bounce back the way it used to be. And actually, nature has a way of coming to a new balance. It's the new rule book. You don't go back to a snapshot from the past. Hands raised together.
What is the system for the poles that you put in the ground?
The system?
Yeah.
Okay, basically, we've got those black pipes are at the center of the reef. It's a fairly small reef, and so closer to the middle of the reef, you get 3 colors, 3 stripes, then 2 stripes, then 1 stripe. And we only go 3 poles away from the center, and different color codes mean a different geographic part of the reef. And so it's sort of rude and crude, and we'll probably use a slightly different system if we get a different reef staked out, because they are very amorphous. Each of these diveable reefs is of a different shape. Good question.
I have 2 questions.
We'll allow the first.
How were the starfishes, how did they melt, and how long did it take for them to melt?
Okay, well, those 2 photos showed you that the starfishes melted in less than 20 days from being perfectly healthy looking to being gone. So probably on the order of just days to a week for the photo you saw of one just falling apart. It happens very, very rapidly, and that's because of a densovirus. So we've published on the virus, but a lot of people objected to that proof that there was a virus associated, saying that doesn't prove why they got sick and died. So we're saying, well, it may be that they got so super abundant because it was a different sort of warmer climate regime, and then we get into these La Niñas where it's colder, and they weren't in as good shape. Their numbers were already decreasing, and we know that they had just had a big reproductive event, so they had a bunch of watery, empty gonads, and suddenly the virus hit, and it hit really hard all up and down the coast.
Second question.
One's enough.
Okay.
What do you think caused the virus?
I think the virus has always been there. We think now, in retrospect, we have seen urchin barrens with green urchins where we've gone, whoa, where'd they go? How many wolf eels did that take? Well, what ate them? Because I tend to think of things getting eaten. And we've had dive resort operators say, you know, we've regularly had divers coming in saying that all the urchins had dropped their spines. Do sea urchins shed spines? Well, no, actually, when a sea urchin dissolves from a virus, all the rotten tissue is inside its shell or its test, and you can't see anything hideous. And I did find, we collected ones for Cornell University. I found one with a piece missing. It had no spine. I looked in, and there's just a tiny ribbon of gonad remaining. Everything else had dissolved, but you just don't see anything that shocks you into taking some action. So we've had lots of, when I started as a scientist, they thought the Australian Great Barrier Reef was going to be totally destroyed by the crown of thorns starfish. They got infected and they died. The Caribbean was overtaken by a long-spined purple sea urchin. They died. We don't know that they had a virus, but they suddenly died. Urchins and starfish tend to get huge populations and then suddenly die out. And there was this guy named Malthus, Thomas Malthus. He was a smart guy, and he came up with this saying that all populations, he was talking about humans, of course, will be leveled by war, famine, and pestilence. Pestilence. He was a smart guy. Think about pestilence.
How long does it take for the sponge to develop?
Good question. When they settle from the plankton, they're little tiny ones. My experience is that typically, unlike baby human beings, they, quotes, fail to thrive, meaning they don't go anywhere and then they die. And it's very rare for them to start growing. And then they have what I call rapid episodic growth, and they can grow explosively. So it's like you grew to adult size by next weekend type of thing. Doesn't happen very well with humans, but some of these invertebrates have that capability.
I was paddling in Parksville with my father-in-law on the weekend, and we noticed he's been on that water his whole life, and he's never seen anything like that sea urchins that it was unbelievable. It was so clear, it looked like it wasn't Vancouver Island. This is just on the New Bay area.
Yeah.
My question is, do you do work for aqua farmers? And there's lots of talk in Qualicum about acid in the water and scallops and.
I know the people at Island Scallops and such, but I'm glad you bring up the fact that Nanoose Bay is full of urchins, because it's not at all uncommon for one or another small rocky reef to have an urchin barren. First thing I ever saw in Howe Sound was an urchin barren, but it was small and had a wolf eel sitting in it getting fat, and because of the sea star die-off, the whole Salish Sea, the Strait of Georgia, Puget Sound, is one gigantic urchin barren, which is unprecedented, which is why I think that the spot pond population won't be wiped out, but it will become rare enough, like these other species we look at that nobody cares about, no human exploits, that wink out during a particular climate regime. They may just live at a level without enough superabundance to allow fishing. And so I can't say anything about the experiences they're having with the scallop industry and such, because we're all very concerned and confused by what we see with acidification and such, and this whole climate regime thing is another twist.
What time is it?
7:50.
Thank you.
Okay, so why don't we
got
see
one
if
right
we've
in front
got
of you.
one more
Right
question
there.
here
Right
before.
there.
Hi, I was wondering if you're monitoring the glass sponges in other areas other than off our coastline, like a little further north or something, where there may not be so many pollutants.
These glass
and-
sponges don't exist north of British Columbia. There is talk of them right on the boundary line with Dixon Entrance, but you have to have a major multi-million-dollar ship to get to the reefs that are up around Guayhanas and such, because they're in very deep water. And the beauty of Howe Sound is that you can go for a scuba dive and you can see them. They are studied by people who have ship time off Galiano Island or Gabriola, and then under the Fraser River plume, but that's all in very deep water and divers can't go there and live. So that's it. I'll let Jonathan take over.
All right. Thank you very much, Dr. Jeff Marliave. How about a round of applause for Dr. Jeff Marliave? So I'd like to thank everyone for coming here tonight. We do have some upcoming talks here at the Vancouver Aquarium. On May 21st, Dr. Peter Ross is doing an ocean pollution workshop, and the focus is pollution solutions. So that'll be on May 21st, Thursday. You can go visit the Vancouver Aquarium's events webpage to get more information about the upcoming events. And on June 2nd, we're going to have the octopus scientists here to talk about their research with octopuses. And then for those of you that might not be able to make it to those events, World Oceans Day is coming up. The aquarium will be celebrating it on June 6th, and also on the evening of June 8th, which is the actual World Oceans Day. So thanks so much for coming with us tonight. The Vancouver Aquarium, we're here to help conserve aquatic life. Dr. Jeff Marliave has been doing it for 40 years by going out into Howe Sound and studying the animals that are out there. There are programs where everybody, citizen scientists, can go out and study Howe Sound and the creatures that live out there through rockfish abundance surveys. Even some of our young biologists in the room today could go out there and learn to dive and start collecting data so that we can help protect our waters. Thank you so much for coming, and we hope to see you again. Good night.